Oh, hi there. Thanks so much for showing up for your learning. Let's give this one another crack. So yesterday, my problem was I really just needed to pay a lot of attention and be really into the game, okay? I really needed to be into the game of math, and I was not reading the question carefully, which was, we have AP, this length here. I don't know what it is, call it X. Well, we're not going to call it X, but anyway, AP times BQ, not like A or B. So that was my problem. Let's label this side A, this side B. The other side is, of course, C. And C is represented by like these few things. We're going to call this length PQX. Okay, because I don't want to call it PQ all over the place. We're just going to use a single letter everywhere. And no subscripts today. Okay, so we can see that like that whole length C is composed of A, which is this radii, and I can move that down there for that circle sector. So A goes from there to there, that's A. And then B, similarly, B would come down here. Boop. And so this would be B. So the whole thing C is equal to A plus B minus X, because like A plus B kind of double counts in X. So we need to take out one of those X to kind of do that. Okay, so that's a way of saying C. All right, so now let's do some left side, right side work. We want to prove these things are true. So we call this the left side of the equation and this the right side of the equation. And now let's just work the left side. Well, I've decided that PQ, like I might even have a sentence up here like let PQ equal X. Okay, so then the left side is equal to 1/2 X squared. Okay, we couldn't get very far with that there, could we? But now let's work on the right side. All right, so the right side, we're going to have AP times BQ equals, well, AP, this is just B minus X, and BQ is A minus X. So that's equal to B minus X multiplied by A minus X. That's all. All right, and so let's keep going. That's equal to, we just multiply this out, AB minus BX minus AX plus X squared. Oh, that's interesting. So our right side so far is equaling that. And we don't really have right now a way to get these two equations to speak to one another. On one side, we believe it to be 1/2 of X squared. And on the other side, it's like AB minus BX minus AX plus X squared. What's going on? Let's make the left side speak to the right side through Pythagorean theorem, shall we? Okay. So we might just flop colors here from Pythagorean theorem. Okay, we're just going to state it. C squared is equal to A squared plus B squared. Why did I write it? It's going to be much better if I don't know why I flipped that. I need so much space for that A squared plus B squared. I mean, C squared, sorry. A squared plus B squared equals C squared. All right, and let's see what we can do with that. Well, C is equal to this, A plus B minus X, which is what we were doing yesterday. So we have A squared plus B squared is equal to A plus B minus X squared. Now let's square it. So we'll start with all the A's. So that's A times A, that's equal to A squared. A times B is AB. And A minus X is minus AX. Cool. Now, let's swap colors for ultimate clarity. B times A is plus AB. Oh, there's two of those. B times B is B squared. And B times minus X is minus BX. And we swap colors once again. We have now this term minus X times A is minus AX. Oh, there's two of those. minus x times b is minus bx, and minus x times minus x is plus x squared. What's all that equal to, you ask? Well, it's equal to a squared plus b squared. All right, now let's simplify this as much as we can. Okay, we're going to subtract a squared plus b squared from both sides, so that gets rid of that, and it gets rid of that. All right, next we're just going to go ahead and simplify. So we have 0 on that side is equal to ab plus ab, so that's 2ab, minus ax is minus 2ax, and bx minus another bx is minus 2bx plus x squared. Okay, now we reorganize this to be x squared is equal to, so basically I'm going to fling all of this to the other side of the equation and fling like this to the other side of the equation so that I get negative 2ab minus 2ax minus 2bx. Okay? Okay, cool. All right. Now, out of curiosity, we've got here x squared. What do we could have a new way of expressing the left side here. If we divide this by 2 and divide all of that by 2, oh my goodness, we have positive 2ax and positive 2bx there. Oh my goodness, it's just annoying. I'm just trying to be clear and being unclear. Okay, so then we get x squared on 1/2 x squared, which is the left side, is equal to ax plus bx minus ab. That's it. Ax plus bx minus ab. That is 1/2 x squared. All right. Now, we also have our useful equation here, this one. So, on one hand, this equals the left side. So we can rewrite the left side as being equal to ax plus bx minus ab. Okay, now let's work on the right side. Okay, the right side here, right side equals ab minus bx minus ax plus x squared. This one here. Okay, because that's x squared, this equation. That is x squared. So it's then plus minus 2ab plus 2ax plus 2bx. And then we simplify, so the right side is equal to ab minus 2ab, that's minus ab, negative bx plus 2bx, that's bx, and negative ax plus 2ax, that's plus ax. Oh, but that also equals the left side that we developed up there. The left side equals the right side. We're done! Where's the intuitive proof here? Whereas you're looking at this and finding your intuition that it's true, I don't know if that exists. I don't know if there's people that look at this stuff and say, oh yeah, clearly, I can square that and it would be this times this. No, I don't think so. This is a kind of like algebraic discovery that I don't particularly understand per se. I can just get the algebra to cooperate and behave. Okay, our algebra is going to behave if you do it right and you avoid errors. And you can prove all kinds of things. And that's quite powerful. This question to me is just a test of how good and how tidy your algebra is and how well you can set it up with the diagram. So this is my approach to this question. I hope that's been helpful. If you have any more questions for me, hit me up in the community. Otherwise, thanks so much for showing up for your learning, everybody. Bye for now.